Go to Kickstart, create project. In project you can press next and change the directory into this PC. This PC D drive, you can create one folder. This PC arrow mark expand చేయండి మేడం, arrow mark expand చేయండి. D drive, select D drive, click on new icon, create new folder, create a new folder icon and give the name, any name, VLSY underscore lab. Click on OK. VLSY underscore lab, click on OK. Then click on select that folder. Select that folder and give the project name anything. You can give any project name. I am giving the project one, no issues. Click on next. Project name is project one. Click on next. Next madam, next button open. Then project type is RTL and enable, don't specify the sources at this time. Click on next. RTL, enable, don't specify the sources at this time. Click on next. Here family is Arctic 7. Family Arctic 7. Categories all. Package FTG 256. FTG 256. Scroll down. FTG 256. Speed is -1. Speed is -1. And you want to select XC7A35T. Second option. XC7A35T. Second one. XC7A35T. In parts. XC7A35T, the highlighted one, see, XC7A35T, click on next and finish. Click on next and finish. Now you are entered into the project manager window. In this window you want to focus on source window and flow navigator window. So this is the flow navigator window. You want to cover all the steps from starting to ending. You can done the debugging part if you follow all the steps. Okay, in the source window select the design source, click on plus symbol. Source window, select the design source and click on plus symbol. Now you want to select add or create design source and click on next and give create file. Click on create file. Now you can give the file name. Click on create file, counter. Create file counter. చెయ్యాలనే కదా సార్ నేను ఇప్పుడు దాకా మళ్ళీ కౌంటర్ వాళ్ళకి చెప్పాలి. గేట్ అనేది అవుట్ అవుతుంది పండ ఏ గేట్ చెప్పమంటారు చెప్పండి. ఇది కూడా డబ్బు అది సేమ్ గేట్ అండర్స్కోర్ ఎక్స్ఆర్. Gate underscore XR. Okay, don't give the XR underscore gate like that because XR is nothing but a keyword. That is the reason. Click on OK and finish. So you want to give the inputs are two input variables. That's why it's a 2 A comma B and output is Z. Output is Z and change the direction to output. Change the direction to output and click on OK. Click on OK. A comma B inch दिया So double click on the code counter and you can write the code here. SI ASSI GN SI Z equals to A XOR B XOR B semicolon control S. That's it. My code is done. This is the code. Assign Z is equal to A XOR B. C equals to మేడం ఇలా కోడ్ రాయండి అక్కడ టైప్ చేయండి simulation. Okay, simulation. Go to simulation in the flow navigator window. See flow navigator window, simulation, run behavioral simulation. In flow navigator window, simulation, run behavioral simulation. Run behavioral simulation. While it is a what happened here? Synthesis అడుగుతున్నారు. Synthesis కన్నా simulation ఇది explain చేయండి. Run simulation, run behavioral simulation. ఒక్కడే చాలు సార్. మీకు వచ్చిందా? Run simulation. So here there is two inputs. So you want to go for right click, select the variable, right click, force constant. You want to give one by one. Force constant means one by one. If you want to give at a time, just go to clock. Raising edge is 1, trailing edge is 0, 100. Another is again force clock 1, 0, 200. Hundred nanoseconds time interval I want to change. Okay, if it is a force clock, ఇచ్చారా రైట్ క్లిక్ nanoseconds కింద మార్చుకున్నాను నేను 100 seconds. మన రన్ టైమ్ ఈజ్ అప్ టు 100 nanoseconds. So click on this triangle symbol T. Okay, after giving that, madam CE istaru output adi. Click on that. So now what you want to see, what you are observed, some 100 nanoseconds has been completed. Total how many nanoseconds are required? 200 to complete the all four cases. All four cases I required another, that means I want to write another 200 nanoseconds. So see, at a time I can get all four cases 0 0 0 1 1 0 1 1.
Okay, I got 200 after nanoseconds.
Not like that. So you want to end the simulator. So see here the blue color tab. The blue color tab is there. Simulator behavioral simulation. Okay, behavioral simulation. So click on that blue color tab. At the end, you want to close simulation. That means you are asking to close the whole simulation window. Yes, I want to close. That means click on OK. If it is yes, click on OK. Do discard. We are not saving anything. That's why we are discarding. Okay, I'll close it. Fine. Right. Now, what is the next step after simulation?
Synthesis.
Before synthesis, there is another step is called RTL analysis. So you want to follow the steps of flow navigator window. That's it. We want to follow the steps of flow navigator window. So click on RTL analysis. Click on open elaborated design. In RTL analysis, click on open elaborated design. Yes, click on OK. Click on open elaborated design. Click on OK. When you click on RTL analysis, it will shows you the RTL schematic. So this is my RTL schematic. If you observe, this is my RTL schematic. Nice. So I want to observe another thing is called Windows IO ports. Go to Windows option, IO ports. In menu bar, Windows IO ports. Then here, what I want to do, here I am doing, మేడం నా స్క్రీన్ చిన్నది కనుక నేను అన్ని మ్యాక్సిమైజ్ చేస్తున్నాను. మీరేం చేయొద్దు, మీరు జస్ట్ స్క్రోల్ చేసుకోండి. Windows IO ports. In below window you can observe IO ports tab. Expand that. Okay. Now you can see if it is here, you can see A, B, Z. So there is a pin number, package pin numbers and IO STD. And another thing is called IO STD is there. This is IO STD. These things I want to fill. These things I want to fill. Okay, the switch I am giving as input as switches L5, L5, L4 are the switches. J3 is my LED. J3 is my LED. L5, L4, J3 is my LED pin. You know that the terminology called UCF, user constraint file. UCF. You want to develop the UCF. This is called UCF. Here it is called as XDC. Here it is called as XDC. Xilinx design constraints. And IO standard is LV-CMOS 3.3. LV-CMOS 3.3. IO standard is LV-CMOS 3.3. You want to change all IO standards. LV-CMOS 3.3. Type change madam. Keyboard lo type change it will come. L5. Select L4. LV-CMOS 3.3. LV-CMOS 3.3. Next with LV-CMOS 3.3. Put Control S. Press Control S. Then it is asking how to save. You can give any name. After giving all things, you can give any name. I am giving pin because these are pins. For my constraints, pins. You can give any name. Okay, and you can see the file extension is XDC. File extension is XDC. Design constraints. Xilinx design constraints, and click on OK. Click on OK. Okay, so constraints is also done. So in RTL analysis, what we did in the flow navigator window, in RTL analysis, what we did only two things. One is RTL schematic, another is we are setting the pin descriptions of the hardware. Pin descriptions of the hardware. Okay, pin assignments has been done. The next step is what? Synthesis. Where it is located in source window, there is constraint file. We saved the pin.xtc, right? It is visualized in source window, constraint file, pin.xtc in constraints folder. In constraint folder, if you double click, it will look like this. If it is double click, it will look like this. This is constraints what we saved. Otherwise, we want to write this much of syntax. Okay. In olden days, we want to write the entire syntax, right? Instead of that, you can use this one. Next one is synthesis. Run synthesis. Here you can take the maximum value. Okay, number of jobs, maximum value. Number of jobs is the maximum value. Okay, click on OK. Jobs is relevant to the processor of your PC. It is not relevant to the software of Xilinx. Okay. So now you can see the top corner, it is running. Maximum ఎంత ఉంటుంది పెట్టండి, maximum value. Click on OK. In top corner it is running. See, running synthesis. Running synthesis. Or you can see in the design sources also. Synthesis has been completed. అయిపోయిందండి synthesis. Click on run synthesis మేడం అక్కడ. Synthesis is completed, then you can click on, if you want to see the results, what is happened in the synthesis. That's why you want to see the results. That is the reason we want to click on open synthesize the design and click OK. Open synthesize the design and click OK. While clicking OK, it is asking, can I able to close the elaborated design. Elaborated design is from where? RTL analysis. That's why I want to close the elaborated design and I want to open. Yes, I want to open synthesize the design. So this is called synthesize the design. Here it is showing something like device. So the inner part of FPGA. This is called the inner part of Xilinx FPGA. So if I want to zoom in, generally, don't zoom anyone. See the screen. If I zoom in, these boxes, blue color boxes are nothing but CLBs, combinational logic blocks. Okay. If I zoom the individual combinational block, inside that is called slices. Each slices consisting of LUTs, muxes, carrier and flip-flop. LUT, muxes, carrier and flip-flop. Okay. Open synthesis. Open synthesizer design. Okay, then fine. So this is the inner part. But what I'm looking is in the open synthesizer design there is a term called schematic. Left side flow navigator window in below synthesis part. Open synthesizer design there is a term called schematic. Click on that schematic. This schematic is called technology schematic. This schematic is called technology schematic. Previous schematic is called RTL schematic. It's a IEEE standard format. Technology schematic is relevant to the FPGA, targeted FPGA. Okay, that's called technology schematic. So this is the one thing you are observing in the results. Another result is, see here there is a term called sigma in the bottom, project summary, sigma. Okay, if you click on that sigma, scroll down, utilization factor is there. Sigma symbol paina.
పవర్ అనాలిసిస్ అన్నీ కూడా ఇందులోనే వస్తాయి సార్.
Sigma. Scroll down. This is called graph and table. You can observe that utilization factor scroll here. Graph and table. You can click on table. Utilization that is called area. Number of LUTs available. Out of that, one LUT is estimatedly used, and utilization factor is 0.01%. Okay. 170 LUTs IO ports are available. Only 3 are used: A, B, and Z. That's why 3. So 1.76% utilized. So this is called area factor. So by synthesis, we are observing technology schematic and utilization factor. Okay. Next, synthesis is completed. Now next one is run implementation. You see timing report or power report, you want to run the implementation part. That's why I'm going to the implementation part. If you observe that, okay. Madam, we already chesaru implementation. So click on run implementation. Give the maximum value. Go with the maximum value and click OK.
పవర్ అనాలిసిస్ అన్నీ కూడా ఇందులో వస్తాయి సార్.
So synthesis will show implementation first, design initialization, optimization, placement and routing will take in place. First initialize the design, then optimize the design, okay, then placement, then routing. These 4 steps will perform in implementation part. These 4 steps will perform in the implementation part. If the implementation is successfully completed, just click on open implemented design. Open implemented design. Yes. So now you can observe again the device here. If you observe the device here in the corner, see in between these two I am having highlighted. One LUT is been highlighted, blue color. This is the blue color LUT is highlighted. That highlighted LUT is known as our design XOR gate. Okay. It is also be routed. See, there is an icon called routing icon, routing resource icon. There is an icon called routing resource icon. If you click on that, it will show how it is routed. This blue line, right? Green line indicates routing resource. Okay. The green line indicates routing resource. Here, sir. This E icon click change, sir. Focusing on time and power reports. We are focusing on time and power reports. So go to project summary, go to power, on chip power. Go to timing, go to power, on chip power. Okay, on chip. Scroll down here. Power, last on chip, then pattern on chip. అక్కడ చూడండి ఆన్ చిప్ అని హైలైట్ అయింది. Make it on chip. Okay, power and on chip. In that sheet, what is the total power here? 1 point something. 1.2. And okay, they are performing NAND, I am performing XOR. Then power differentiation is occurred. Okay, manual got 0.7, 0.7, mine 1.2 something. But instead of that 1 point something is not an actual power. Our actual power is nothing but our design, our logic. So the logic power is how much? 0.003 watts. That means 30 milliwatts. You can go with 30 milliwatt. NAND is 20 milliwatts. 0.002 watts. That is the logic. Why 1 point something is came is because you given that LV CMOS 33. That means the input and output voltage you are applying around 3.3 voltage directly. That is the reason the output power IOs, input and outputs, have 1.2 watt. Okay, so we are not considering on 1.2 watts on that factor. We are only concentrating on actual logic power. Okay, our logic is an XOR gate, our logic is an NAND gate. Okay, that is our logic. Nice. Then coming to the delay in the flow navigator window, implementation, open implementation. In the flow navigator window, implementation, open implementation, report timing summary. Report timing summary. Click on report timing summary and click on OK. Click on report timing summary and click on OK. No. Still. See in the block below. So here in the timing summary, timing report is there. Bottom window. In that you can see there is unconstrained path. Timings, unconstrained path, none to none, setup and hold. Both the things are there. Go to setup. Here the total delay is nothing but the combination of logic and net. Total delay is a combination of logic delay and net delay. Okay, explain. Total delay is a combination of logic delay and net delay. Okay, logic delay and net delay. Then it is from B to A, B to Z. Input is from B and Z out to Z. What is about hold? A to Z. Hold is A to Z. Total delay is 2 point something. Setup delay is 8 point something. Okay. If you want to see the schematic of that path, then click on this symbol. Select the path. Select the delay path and click on the symbol. It will show the from where to where the delay will be occurred. Select the path first. Select the path. A path is there. Then symbol. Schematic symbol. Okay, got it? Like that, all three factors we want to observe. Area, power, delay. Area is from schematic, sorry, synthesis. Implementation from for both power and delay. Implementation is also done. Implementation is also be completed. Then in the flow navigator window, what is the next step? Last step.
Program
and debug. Program and debug. So for that, click on generate bitstream. Generate bitstream. First one is generate bitstream. Generate bitstream. So bitstream is running in the top notch. So bitstream is completed. Bitstream is completed. Sir, we cables kuda marchesaru sir. Ee cable didi gaadu. Deentlo pettaru. Okay. So until unless bit file is completed, you don't turn on the hardware. Okay. Bit file is successfully completed. Just I'm connecting the USB port and my hardware, then I am turning on the hardware. I turn on the hardware. Now I want to program, so that's why go to open hardware manager. Bit file is successfully completed. Steps fast one. Bit file is successfully completed. Click on open hardware manager. Open hardware manager. Click on open hardware manager. Click on OK. Click on OK. Open hardware manager. Click on OK. So now you are in hardware manager window. Here if you observe, the hardware window is empty. The hardware window is empty. For initial state, you want to go to open target. In the green line, there is a blue line is there. Blue letters is there. Open target, open new target. Open target, open new target. Select open target, open new target. Open target, open new target. Next step. Here it will identify trace what type of hardwares are connected. Okay. So just 3 times next finish. Next. Here identify the connection. Next. Now it is searching for the connection. Allow access. It is searched. So here we can observe. Here part number is here, it is there, it is not visible, but click on next and finish. So see here everything is been done. Now if you are observed, the hardware window is filled. Hardware window is filled. So what is our part number initially? XC7A35D. Same number is appeared or not if you want to observe. If it is appeared, it's good. Otherwise there is a issue. Okay. So now what I want to do? Right click program device. Right click on that particular part number. Right click on the particular part number. Program device. Right click on the same part number. Program device. Then click on program. Right click on the part number. Click on program device. Then click on program. See here the bitstream file is automatically fetched. You are not bothered about the bit file where it is there, how you want to browse. Automatically it will come. Just click on program device. Program. Then you can see there is one LED is blinked. Okay, this is called done LED. This is called done LED. This LED is called done LED. Then I want to use my switches to see the output. I want to use the switches to see the output. Both are on, then output is 0. Both are off, output is 0. Any one is on, output is 1. Because it's an XR operation.
Output is showing.
Output is an LED part. Output is an LED part. These two are the input switches.
For input switches, it will not be display the.
ఉన్నాయి సార్. So
సార్ స్విచ్ ఆన్ ఆఫ్ అయినప్పుడు ఇదేమీ మనకి ఎల్ఈడి మామూలు ఎల్ఈడి కాదు దీన్ని ఓన్లీ అవుట్పుట్ ఎల్ఈడి.
అవుట్పుట్ అనేది అలాగనుకుంటే మిగతా స్విచ్చెస్ కూడా ఆన్ ఆఫ్ చేసుకుందాం సార్. ఇక్కడ చూడండి
లేదు. ఓకే
మనం ఏది ప్రోగ్రామ్ చేస్తే ఆ ఎల్ఈడీస్ ఆ స్విచ్చెస్కి మనం ప్రోగ్రామ్
ఎక్స్ఈడి ఫైల్ మార్చేసుకుని సెట్ చేస్తే ఇప్పుడు ఇదంతా చేయకుండా నెక్స్ట్ టైం ఎక్స్ఈడి ఫైల్ ఉంటుంది అది ఎక్స్డిఎస్ ఎక్స్డిసి అది క్లిక్ చేసి మార్చేసుకుని సేవ్ కొడితే రన్ అయిపోతే కంపెనీ చేసేస్తాం.
మధ్యలో ప్రోగ్రామ్ ఏది
ఆ ప్రోగ్రామ్కి ఇప్పుడు అక్కడ ప్రోగ్రామ్ డిస్ప్లే అవుతుంది కదా.
ఓకే మీరు పిన్ నెంబర్స్ వేరే తెద్దాం అనుకుంటున్నారు. వేరే పిన్ నెంబర్స్ అవుతాయి సార్.
క్లిక్ చేసి సేవ్ చేసుకుని
వేరే నెంబర్స్ ఇస్తాను,
సేవ్ చేసుకుని
సేవ్ చేస్తాను. ఎస్